Before introducing our first keynote speaker for today, I would just like to thank the sponsors of the conference, Rivian, the World Bank, Bosch, but also Play Studios and Wargaming, and to start this journey of discovering the use of data and AI in video games and interactive art. So our first keynote is Konrad Tollmar, a research director from Electronic Arts. He has also delved in academia before joining EA, and his research areas are user-centered communication technologies, mobile services, and market research and analysis. But today, he will give us a glimpse at how things are done at Electronic Arts. So to use a greeting from one of their top games, The Sims, so Konrad, the stage is yours.
There will be quite a lot around machine learning and AI in this part, but I still would like all of us to keep in mind why we do this. And that is to, first of all, sort of get into better games, better new game experiences, but also how we can improve what we just heard about, the tools that we use when we create these games. So, I guess you know a bit about who we are. So this is some of the games that we have published and created. Maybe some of you have played this. I mean, FIFA is not anymore called FIFA, it's called FC. And there is one game missing here, that's Battlefield, of course. But to get a bit into the mood of the games or the game worlds that we have, I would like to share a short video first.
Dream in every color, and we come alive. This is where our dreams begin. We all can see if we just wait.
So, first pop quiz here for you, and we are such a small group here, so feel free to jump in with questions and just raise your arm at any point, and then we'll probably have a Q&A in the end of it as well. But did you note any AI here in all of these games scenes that you saw? Some? Yeah, please speak up. Yeah. Correct. And I think this is a bit where we might get a bit confused, because we have, in the gaming industry, talked about game AI for 2 decades. And that is how we control the MPCs and the agents and all the things that are going around in these games worlds. But still, I mean, this is not really AI as we see it today. So I think if you ask the question, do we have any modern AI in the games today? I would say no. I mean, not modern AI in the way that you learn something, and then this AI actually evolves during the gameplay. And I think there is a lot of good reasons for that, because game developers don't really trust AI as it is now. And so what we need to do as sort of researcher and developer is, of course, to advance that and make it more trustable and more useful. But then I would also say that there is a third answer on this, and that is that there is actually some AI in the games. But it's not like the evolving AI which learn, but it's more like how we use machine learning for some specific features. And I will come back to that and provide some examples of that. So this is the first example. This is a system called Swish. It's a cloth simulation. It's an ML model that is learned by how cloth moves on characters. And if you see the old system where this was handmade, I mean, this was really much the best attempts, and the time and effort that was able to put into this. But it still, as you see, lack a lot of quality. But the ML version that we have now, it's actually in the game. So the cloth simulation happen in runtime when you play the game. And hopefully you will see the difference here in the quality. And that is like the small things that adds up, I think, in how we infuse machine learning and AI into our games. And I will talk more about this in a sec. So, but then we should also, of course, remember we have a lot of gamers online. So in the more traditional way of like data science, then of course we do quite a lot. Getting sort of player data, being able to create the best game experiences by having sophisticated matching algorithms. But also I would highlight here two other things. And one is a program we call Positive Play. Because unfortunately, it's not sort of having all these 700 million players, it's good and bad. And we also need to be aware of there is cheating online, there is fraud, and there's bad use of language, etc. And for keeping a good player experience, a positive player experience, we need to deal with all of that. As well as we also need to make our games accessible. And that is sort of the second pillar here, that we have a program about accessibility technology, which we also open sourced. So this is like available for any game developers actually to use when you develop your games. So these are the two more like how we use data science. But my focus today will actually be more on the creative side of things. And I'm from SEED. SEED is a cross-disciplinary research team at EA. We are about 50 people worldwide. And we are on the mission to explore the future of interactive entertainment. And of course, we do a lot for the game studios and the actual games, but we also try to research and innovate ahead of this. And hopefully this will come across in my talk. So I will share a short video where you can get an overview of stuff that we have been doing recently. So that was a bit of a collage of the greatest hits, and sort of my plan now is that I will take you through 3 areas that we are particularly focused and interested in. And the first one is called Advanced Avatar. And this is really about like, what is the most important part of a game? That is the characters. And how could you make this character to become as visually conceiving and natural as possible? And what we strive for as a company is, of course, to reach what we call cinematic quality. So when you play our games, it should feel almost like you're watching a movie. If we take the Swish example again, if you walk through this, like you see the dynamics here in the class simulations, but also how the actors or the MPCs interacting with each other. But there is also a lot of other cinematic effects here. You see motion blur and focus and so forth. But you also see how these characters moves and how sort of they behave or interact with each other. Another important part here is, of course, to make the faces or the heads become as natural as possible. And for this, we are developing a new tech which we call the light stitch. This is sort of not really so new. It has been in the oven for almost 4 or 5 years, but it's basically a dome of high-res cameras. And what you do is that you put actors in this dome, and then there is also light, so you can move the light sources, and then you have a script, so you do a recording which lasts for 15 to 20 minutes. And based on this, all this data, typically a session generates up to 10 terabytes of data, actually. And now we have captured maybe 100, 150 actors here. Now we start to be able to build an ML model that could generate this artificial head. And what you see here is one of them. And this is maybe a bit beyond what we can use in the games as now in terms of quality, but we start to see more and more ask from the game studios where they need to have more naturalistic heads for their games. So this tech started to deliver in that way. The next area is intelligent agents, of course. And this is a bit beyond what I earlier talked about, like just having an ML solution into the game, but also how the MPCs or the agents could learn how the game is played and like adapt and learn new behavior here. So, this is where it all started a couple of years ago. We had a simple game, and this is one of the challenges in actually deploying this, and I saw in the program there was a talk later on today in how you make this happening, and this is really one of the hard part even today, like how do you make this working in runtime into the games. But here, this agent's trained for a while, and after 24 hours, it's probably get it fairly well. I think we today have better and more efficient algorithms, so maybe it doesn't take 24 hours, but it takes a while still. And interesting also is like without telling this naughty little agent learn how to cheat, believe it or not. So they could explore like how to position the ball in the best place, and most funny here is like it could even use the game controller to kind of flip, as you know, if you play this game. This was not something we told the agent. It just learned how that was most efficient way to get to the end goal. And of course, what we then start to realize, well, this might be a bad thing for a game, but it's not a bad thing if you would like to test a game. So one attempt here is to use this reinforced learned agent to test the games. And what you see here, and I will give you some more examples soon, but this is how we have played around with how you can integrate that into the editor, because typically this is a very long procedure. Well, you builds a feature in the game, you build it, you ship it to the game testers, and then you get a feedback if how it works or not. In this way, we can have agents actually in the editor and make it possible for the game designer to sort of test different parts of the game while they're designing it. And then, of course, we also moved on from this, and this is sort of a paper we presented 2 years ago at the Computer of Game conferences, where we built a more large-scale world. And one of the learnings from this one is like, well, you probably need to equip the agent with some kind of personality to test different kind of bugs or be able to exploit what kind of problems that you might have in the game. So we in the first attempt here, we try to make this agent a bit more curious. So not just having as goals to reach certain objectives in the games, but also that it should aim for coverage, so that it should search all over the game area as in the best way. And what you see here in the end is like, then when you have all of this data, you can also reverse this and then tell how the agent went from A to B and sort of map this or visualize these graphs in the movement in the game scene. And this is something that the game designers have found that it's very useful for them, because the agent itself, it doesn't tell you anything. So you can pull all these agents in, but you need to come up with different ways of showing what they have been doing afterwards. And this is one of the way you can do that. The next example here is a bit of a twist on this, where we have one reinforcement learned agent that play it, actually the drive the cars here. But as you see, if I play that again, okay. We have in this case another agent that actually generates the road. So typically a reinforcement learned agent, this is the schema, it observes the world, it gets some rewards for things it accomplishes, and that is like turned into different actions. But in this case, we added another agent that are generating the world as well. And if we then could add a feature or a function here, we can actually control the difficulty. So we can get an agent that basically tests different kind of levels in the games and tell the game designers afterward, okay, this is a level that have this kind of difficulties or this kind of problems in it. However, reinforcement learned agents are not that easy to tame, and even us as researchers have difficulties to create the rewards and shape the policies and making them actually working in the game. So another take on this is like using imitation learning. So the idea here is that the game designers could demonstrate how the game should be played, and then that is feedback to the reinforcement learned agents. So they work a bit in a pair. So, and this is also coming back to this issue on how could we make the game development more efficient. And typically, as I said before, you have a design, you need to validate, you need to review it. And the idea here is really how you can bundle this together and get that into a much more efficient development cycle. And an example here, it's a simple test, but a game designer could then show how you move in a map to reach a certain objective. It demonstrates this a few times, as you see here in the video. And then when it has done so, as you will see, you can train it, and then it actually takes that data, and it doesn't need to be demonstrated that many times. A handful, up to a dozen, it will do it most of the time. And then it could actually solve this task. But then a designer could, with this agent, also test different kind of designs of the world. So if you would like to move in certain obstacles or you remove the fence, you will see that somehow the agent still sort of solved this. And another scenario here is like where the agent also has a prop, so he could like shoot. But basically, it's the same story. You show something, and then you quickly train an agent to do this, and then with this trained agent, you can start to iterate and design on the world in a more better way. What we then learn, of course, is like, again, well, the personas of how you play the game is very important. And I mean, there is not just one single type. Some play the games more aggressively, some play it more calm and would like just to have a good experience, or some would like to just more observe and looking around and so forth. So we have aggressive, calm, and sneaky here. But you know, artifacts in gamers, we have like 6, 7 different types that we usually work around with. And what we then did was to actually, using imitation-based learning, to illustrate different kinds of archetypes. And here we have 2 archetypes that we have trained on. One is calm, and the other, or careful, and the other one is more aggressive. And then when we have these 2 models, what we have here, and this is a paper that actually got the best paper award at COG this year, is how you can mix these personas together. So you can, using this data, you can actually create a new persona that sometimes plays a bit more aggressive and sometimes plays it a bit more careful. And I think this is the way to move forward now, to explore more of these archetypes and be able to like show or demonstrate this different kind of game plays and use that for the game testing. So that was the second. The third area where we look into and that we are very interested in is, of course, Gen AI and generative art. And maybe not to the point where we imagine that AI will generate a game completely from scratch, bottom up for us, more in how could you use AI to improve the quality, like you saw in Swish, or how could you make tools that sort of enable the artist to build better or design more better games. But then AI is not so user-friendly, as we know. So then we need to think, okay, how could we make these tools more accessible and useful? And I will show you 2. We'll see, what time is it? Oh, it's plenty. I will show you 2 examples here. One is voice-to-face. It's a system where you could generate lip animation based on speech.
Voice-to-face generalizes to multiple speakers never heard during training. In this video, we show a few examples of animations generated by our model.
This was well nigh encompassed by a wall of sheer cliffs toward the east and the great mountains.
Piercing shrieks, unequal quarrel on a staircase, the sharp bang of a door.
"I've just come from the post office," began Ruth eagerly. "As I was coming out, 2 men almost bumped into me."
And this is sort of the technical description of the system. It's a variational autoencoder that creates a latent space, and then through that latent space you can then control the mesh animations. So, but I will not go in detail in how it technically works. We just wanted to show this illustration of how the system is built.
Los dos sacaban las vacas a pastar en el campo.
Sorry, I stopped there. What we also been able to show then is like you can use this model now to like create lip animation also for other languages and even expressive speech.
Los dos sacaban las vacas a pastar en el campo, y mientras Damián, echado en la hierba, procuraba dormir o no hacer nada.
Cudowność wieści o pleniu budziły w nim żądzę zbadania tego dziwu przyrody, ale lata mijały, a cud się nie pojawiał.
Fräulein Jettel nahm nach einem Seitenblick auf den Geheimrat eine sehr vornehme Haltung an und hub an, also zu sprechen.
For a fair comparison, here we compare our approach to VOCA, a state-of-the-art method trained on our data.
And you don't think maybe I ought to have had lemon custard to go with the pumpkin instead of the mince? Miss Marilla Chadwick turned from her anxious watching at the kitchen window.
It is a good family, and blood is worth more than money, so I let him alone.
Finally, by varying the latent vector used for inference, voice-to-face also allows control over the overall speech style of an animation.
It was the time of year when the ground is carpeted beneath the firs with brown needles.
There, where he was appointed by his superiors to give lessons in philosophy, the young novice had from the first to battle against the defects of a voice that was both harsh and weak.
Well, why didn't you give it to me at once? Where are my glasses? The aunt waited meekly while her sister found her glasses and read the telegram.
Thank you for watching. For more information, check out our paper at go.ea.com/voice-to-face.
That was a bit of a promo for that. But I guess you get that also connect this to the Swish project that I previously talked about. So this is a thing when you create this character that takes enormous amount of time and effort to do well. There is particularly two things that you need to do, watch out for. One is, of course, the lip movement themselves and how you time, particularly when you close the lips. But another thing that I should maybe have pointed out in the beginning so I can watch it in the videos is the tongue animation. So a lot of this system that is out there today, they just move the lip, but they don't animate the tongue. And we saw then that when we added the tongue animation, the user feedback, or when we evaluated this, went up very high, or way better. The next thing, and this is a bit further down the road and looking ahead, is the Genoa challenge. So this is also how we can generate upper body gestures from speech. But our take and our approach here is somewhat different. So rather than just developing this in-house ourselves, we actually have also been going out to the academic community and introduce this as a challenge at one of the major AI conferences on multimodal interaction, ICMI. So we have been running this 3 times now, and this year we had also added the data set, so there is not just one character that enact, but there is 2 characters that talk to each other. This is sort of how the challenge is set up. We have a public data set, and then we also have a standardized way of visualizing, because we don't want the evaluation to be reviewing how the quality in the visualization. So that is a bit sort of rudimentary by purpose. But then we also have a standardized evaluation criteria, so a way how people could review the outcome of this. And then the challenge is really here, the green box. And this year we had 12 different teams worldwide that participated. And notable is also that the winning team here was a team that both had like an industry partner and as well as an academic university. So I think this is a sort of a sweet combo also for us, how we would progress and could do research with external partners in the future. And
challenge results.
Oops. Let's see.
Challenge results. First, consider these 2 samples. Which one is the synthetic motion?
I was cracking up at that whole scene. He was like cracking me. I like him a lot. He's one of my favorite characters. But yeah, that was a really good.
Was it the left or the right? Actually, both of them were synthesized.
So with that said, I think I sort of start to head into the end of this. I just would like to also talk about our partners that we have. So we work with both academic and industry partners, as you see here. So feel free to reach out to us if you have any sort of things you would like to do or ideas you would like to test. I think we have plenty of time now for Q&A. So yes, please, thank you.
This one works? Yeah, okay. Thank you very much, Konrad, for the talk. It was really interesting. I personally myself never thought about applications of AI in the way that you did, like testing to kind of mitigate the Q&A factors of, you know, and you know, again with the artist animations as well. But you did mention something that the gaming companies are kind of hesitant to implement AI agents within a game to control NPCs. Could you maybe elaborate a bit more about that? What are the worries, and will this ever will AI ever be implemented in controlling the NPCs, and to what capacity do you think that'll happen? Sorry for the long question.
No, I love it. So I'm just thinking what I should say. And I think my positive answer to that is yes, we will eventually see real AI controlling the NPCs in games. But it will take a bit of time. I actually, a bit of a parenthesis here, I used to do research on, before I joined EA, on self-driving cars. And then, you know, 10, even 15 years ago, we thought, well, now everyone has a self-driving cars. And of course, we see no one have a self-driving cars. So there is a lot of reasons for that. I mean, it's not just the tech itself, it's also how you trust the tech and how you deploy it and different kind of policies, how you control it. And also giving the recent debate on AI and ChatGPT and so forth, I think we're all aware of, well, AI has sort of a problem in that it's not so controllable yet. And I think that is sort of the fundamental reasons why game teams are resistant or reluctant to adapt fully to this yet. They see the potential, but they also see the risk. If something is not controllable, they rather still say, okay, this looks interesting, but now we have a game to ship, let's do it the old way. And then that continues. So that's one of the part of the answer. The second part I would say is I think that a lot of the game and the game engines are not ready for this tech yet. And we see that also when we demonstrate prototypes. Well, we get the feedback, okay, cool, well, we really want this. But in our sort of, when they compute in how much time you have on the CPU, they will come to the conclusion, okay, yeah, but we really would like to have these explosion effects. So I don't think we have the resources for your ML solution yet. And that is still an obstacle. And I think that in itself might not even be solved until we'll see the next generation of consoles. Because if you think about how games are, our games at least, are developed and sold, like 90% of the games are on consoles. And it's that controls basically what tech is ready for being used when you distribute the games. Swish is a bit of an exception, but it's a very tiny ML model. But I think what you might see now is like a few more examples like that. You might see voice-to-face coming up in actually a real game, but not to the large scale yet. I think we need to wait for the sort of PlayStation 6 and forward before that happens.
Okay, thank you.
Hi, thank you for the great presentation. My question is actually similar to Miloš's. Talking about the games, game designers actually want to ship, let's say, a more or less streamlined experience. How do you think that including AI in the future actually is in line with that? Do you think we will ever be able to include AI in such a way that you say that it's not controllable still, but can we control it in such a way that we still can deliver a streamlined experience?
Yes, to a certain degree. I think some of the examples that I show demonstrate that. But then they are fairly confined and controllable. I think there is other examples coming a bit later. One is like when you have very complicated physical modeling, or for example, you have games where you have weather phenomena that is completely unpredictable almost. Then you need new approaches for controlling some of the agents in those kinds of games, which you can't really do with the current version of scripted AI. Then I think it's also a matter of trust here. Eventually, we need to develop better tools and user interfaces so game developers could access this and understand this. Imitation-based learning, I think, is one of these approaches. But then it's also a matter of just growing into this. So eventually you will see that the effect or the impact is so good, so you want it more. And I would say that we already see that to some degree now. So one example that we don't have any public demos around is, of course, large language models and how those could drive the MPCs. This is certainly something that will come. But we still need to work on how you can create these dialogues and how you can create the storylines and that the game developers could start to trust this.
Thanks.
Probably have time for one more quick question if anyone wants to ask.
Thank you, Konrad, for the great presentation. I just have one question around technologies you're developing at Seed. So are they predominantly servicing the needs of EA and the products that EA is developing? Or once you kind of finish a project and you have a tool or a piece of technology that is usable, is it then used inside the company only, or it's also kind of available to other interested partners, or maybe some of it even is in the public domain? I don't know. So just this aspect of kind of deployment of the things that are working.
No, it's a good question, and I don't really have a good answer yet to that, and that is sort of also the way we operate and the way we actually try to sell, both internally as well externally, that what we do is sort of state of art and sort of drive this field forward. But of course, we are greatly influenced by academic research. And I would say not half, but 1/3 in my team has a PhD and come from an AI background. And with Gen AI, large language models, etc., this is knowledge that the company didn't have before. And we need to develop that. And then there is other things like the light stage, like I showed here. That was not really asked for. It was an idea that also came out from a university collaboration. And this is sort of the hard sell now, that actually we have many examples where we have invented stuff, and the company has been, okay, that's interesting, but yeah, not really useful. And now they thought, oh, we need this now. But of course, we also, with the awareness of AI, I would say that we get more asks for doing things. And the game, I mean, there are advanced computer science people mostly in the game teams, and they have nowadays also maybe taking 1 or 2 ML AI courses, so they start to ask for things now. Yeah, so it's both.
Thank you.
Thank you very much, Konrad. And here is a certificate of appreciation for
Thank
your
you.
participation. Thanks for the great talk.
And I will be here for the rest of the day, so if you have any further questions, just bump into me. Thank you.